Okay. So the meeting is being YouTube live recorded, streaming live. Okay, so basically I will have to leave today early. Oops, sorry, I think. Okay. There was an echo. So I'll have to leave early today, but I'll be connecting from my cell phone and I'll be listening in. So today's moderator would be Mr. Srinivas. You all must be knowing about him. Most of you met him, yeah, all of you met him, right? Yes. So you know him, he's very knowledgeable and he has tons and tons of stories to tell you all, to connect you to the reality of what's going on with solar or anything related to STEM. So saying that, can someone let me know what we did yesterday? Quickly. Yes, Rasya.
We decided to choose a building from downtown Atlanta and find out how much energy it consumes every day, and also check. You also told us to check like a question like how many solar panels does it take for it to sustain a building, and how big is it?
That's good. Good. Excellent. And then the next one is what we're supposed to do today. Other than Russia. Yes, please, Giselle, go ahead.
So today we're supposed to think of solutions to develop a smaller solar panel to conserve space. We wanted to make it more area efficient.
Okay.
And we also needed to find like how big the panel would be.
Yeah. So yeah, partially correct. But before that, there is a prerequisite is you need to calculate how many solar panels are needed for the building that you have selected to generate that much of energy to sustain per day or a week. So how many solar panels are needed? First one. And how much of square footage of area is it gathering? Someone please type it in the chat box. These questions. How many solar panels are needed? To generate electricity for the building that you all have selected, your individual building. I don't want any building, your building. Okay. And then, did someone type that in? Okay. So the second part of that question is, how much area will those solar panels occupy? And then the third question is, if you want to install those solar panels on your building, on your selected building, where will you put them? Will you have enough space to put them? Do you have to design some other innovative idea to, generate electricity through those solar panels? How are you going to connect them? Forget about connecting them, but where will you place them? How are other countries or cities or people who are using solar energy are being innovatively placing these panels on their building, over their building, around their building, inside their building, outside their building? What are they doing, right? So that is the third question. I have given you most of the answers in my question itself. Any questions, kids? Did you post the third one too? Good job. Okay. All right. So can I hand this over? Any questions, kids?
No questions,
okay.
no ma'am.
Okay, good, good. All right. So I'll hand this over to Mr. Srinivas. Mr. Srinivas, it's all yours. Usually what we are doing is we talk for like few minutes and then give them like 10 minutes to research on their own, and then they
Sure.
come back. So that's how they are doing it. Guys,
Okay.
now that I'm not adding that, I can share the whiteboard and you all can add over there. If you are not able to, then probably just put it on your OneNote, okay? Or Word document.
Can you repeat that again?
Which one, Nikki? What questions?
No, what you said just before?
Okay, so this board, you use this board to type in your suggestions or answers. And if you are not able to use this board, then open a Word document and type in your answers over there or your research work, okay?
Ma'am, the
Yeah.
board is completely gone except for the sticky notes.
I know, right? But that's fine. You all know what it is, right? So,
Some of my stuff got deleted. I made
Oh.
my 2 sticky notes were deleted.
oh, how did that happen? Okay, so we will we will work on creating that thing later, but right now, open this. Let me. I'll give you a frame, custom frame. Here, this is a custom frame. You can put your sticky notes here, or you don't have to use this frame. Just parallelly use sticky notes, guys. Just add few more sticky notes here. Okay? And then answer the next question. Got it? Okay, so I'm gonna hand this over to Srinivas. Mr. Srinivas, you can take the first question, talk to them about it, see their
Okay.
understanding, and probably explain few things. And then if they need any,
Sure.
then you can go from there. Okay. All right. Thank you so much, Mr. Srinivas. I'll go on mute and off camera.
Sure. Okay. Shall we start with the first question?
Yes, sir.
So what is the first question? Who is going to read for me? What is the first question?
Would you like us to discuss the board?
I mean, better, explain to me, read for me.
Mhm. Okay, well, the first thing that we did was decide which downtown Atlanta building we wanted to choose. So we each have our buildings if everybody wants to say them.
Rasha, go ahead and explain me what is the first question.
Okay, the
Repeat.
first question is the building name, which I choose Bank of America Plaza.
Okay. So you have selected your own buildings, right?
Yes, sir.
Okay. So suppose your bank building, right? So how do we know how much energy is required to the bank building? How do we know?
If we multiply by its square foot,
No, I'm not asking you how much energy we can produce on the roof of your bank building. I'm not asking you about that right now. My question is, not the energy from solar. So far, we have not installed anything on solar. As of now, your bank is working on the regular electricity, the power company. Okay. So, as of now, first thing what you all need to know is how much energy they need for their bank purposes. So how do we know that? Sri Darshit, do you have any idea? How do we know?
How do we
The
know
power
what?
requirement, the power
Oh, the-
requirement of that bank?
'Cause we have to take the square feet of the building
No,
and
no, no,
then
listen to,
multiply it by
no, no,
6.
no, no. Listen, Sri Darshit. Actually, so far, we suppose, for example, we don't know the roof area. We don't know the roof area. How many square feet, how many square meters, we don't know. We don't know the length and breadth of the building, okay? But we just want to know how much energy is required, how much electricity is required to run the bank. That is more important. So how do we understand that is my question. Giselle?
Yes, yes. So we found out that the minimum kilowatts
How do we know that?
was
My question is, how do we know that?
um
I'll give you one hint, Giselle.
mhm.
You are staying in a apartment there. So how much electricity you need a month? How much electricity you need there for your own apartment? How do we know that?
Well,
you
we
need
have
something, and Nikki might be needing something else, and Sridharshit might be needing something different. Okay, Rashia might be needing some more thing, something else. Okay. So everyone, every home or every building, every commercial complex might require different electricity requirement. So first thing we need to know that.
yes, sir.
Okay, before you work on to, making it work on solar, first thing what we need to know, what is their power requirement? Okay, what is their electricity requirement? So why you guys neglected that point yesterday or day before yesterday's work? Without knowing that, how do we know? How can we
Well,
provide that power? Or we can provide more, or we get less and then use something else? Then these are the most important. Yes or no?
yes, sir. Yesterday we
Okay.
did figure out the minimum and maximum electricity for each of our buildings
Oh, okay.
by
Suppose
by month.
no, Rasya said that, she is working on a bank building. So for example, we'll take only the bank building at this point of time. So my common question for all of you guys is, how do we know? Suppose Rizal might have chosen her school building, or she might have taken his complex, shopping complex, maybe Home Depot, nearby Home Depot. So how do we know how much electricity they need for their own purposes? So how do we know this? Come on, hurry up. Someone to tell me answer.
We know
Anyone can.
we may know this based on their electricity bill or
Correct. Yes. So we can take an average electricity bill, right? Because suppose say last month, if you take the last month electricity bill, that might be different than the bill of the January, okay? Because it depends upon, the season, the heating and the cooling, all these things vary. And the people, sometimes all the people may not be at home. Oh, there are so many factors. So ultimately what we need to do is, we need to take an average of the year long, sometimes even 2-3 years average. Then we will understand. You understand? So at least we must collect some data from that building electricity needs and take an average. For example, I'll tell you, who said, Rasya said that, she is working on a bank building. So, for example, I came to know one bank required the power requirement of a bank on which Rasya is working is around 25 kilowatt. Okay, note it down, all of you guys note it down, this number, 25 kilowatt. The bank on which our Rasya is working requires electricity of 25 kilowatt at any point of time. On an average, I mean to say, on an average. Sometimes they might be using only 15 kilowatt, sometimes 20 kilowatt, sometimes only 10 kilowatt. But a maximum power, what we have seen, is 25 kilowatt. They never used at any point of time more than 25 kilowatts. So that's where I said, okay, let us take the bank requirement power is the required power. The maximum required power is 25 kilowatts. Okay. Now, how I came to know about this maximum power they require, the electricity they require 25 kilowatt? Because I keep on observing with my energy meters. The meter which records the voltage and the current, multiplication of these two, the voltage and current, is going to be the power. Power is the product of voltage and current. So, United States, when the voltage is 110 volts AC, and based on the loads connected, they'll be pulling amperes, currents. Currents are measured in amperes. So I will install the meters to measure the voltage, current. I can multiply the both, or directly these days, you get them like energy meters. I have an energy meter here close to me. I can show you here. I have installed to my recent innovation. Can you see one energy meter here? Can you see one energy meter here? So this energy meter can measure the voltage, current, and the power, kilowatt hour, all this kind of. Okay, later we can work on that meter. But basically right now what we need to know at any given point of time, how much energy is consumed by the building. I mean, there are many rooms inside, many offices are there. I mean, bank itself will have a lot of branches there inside. So based on that required machines to be on, air conditioning to be on, all these things. Finally, minimum 5 kilowatt they required at any point of time for their security systems and all that. And then during their day operations, that power consumption, the power requirement go even up to 25 kilowatt. So that is the power requirement. So have you written the power requirement of that building is 25 kilowatt? And then we need to calculate how much they can harness from sun. That is limited. That is limited because that is based on the roof area available. So if the roof sufficient enough to produce the 25 kilowatt, we are happy because directly we can use that. Or if at all, if the roof helps us to produce 50 kilowatt, very good, very, very good. We can use half of the roof and keep the rest half of the roof for future expansion, or produce extra 25 kilowatt and supply back to some other offices through net metering. Okay, that's another different scenario. Suppose say, if we get only the roof helps us to produce only 20 kilowatt, but we need 25 kilowatt. We cannot keep our machines shut down, and that's where we need to use our brains to compensate, to develop through some other techniques. So this design thinking will help you to raise your creative and critical thinking. You understand, Jason?
Yes, sir.
So yes, sir.
Now we are looking for such kind of out-of-box ideas. So that's where I said, what are other, so for this, what is that hint and help I can do right now? you all need to know basically, as you are there in United States, Atlanta, Georgia, and all that. So what you need to know, what are all the various kinds of solar panels available? I mean, the poly or nano, or what kind of solar photovoltaic modules are available, and what are their standard dimensions, and in which standard dimension, what is the maximum power that they can offer. You understand? So this is very important. You understand? Sridharshit, are you following me what I'm saying? So this is very important. So if at all, suppose say we have maximum roof area, and the area is not at all a problem, in that case, we don't have to invest much money going with bifacial panels or mono panels or such kind, right? Even polycrystalline can do, because we can use the area. Area is not at all a problem. Okay, in some cases. But in some cases, no. We have a problem with area. So we cannot use polycrystalline, because in that particular given square meter area, the power produced by polycrystalline is much lesser comparatively than the nano panels. So there we have to. In some cases, even we need to, because the place is not at all sufficient, in such cases, we need to use bifacial also. So you need to figure out, today's task for all of you guys is, okay, are you following me? Nikki, are you following me? Rasya, are you listening to me? Are you there? Naini,
Yes,
are you
sir.
there? So today's task for all of you guys, do research, okay, and understand panel size. For example, I wanted to help you guys to make you understand. Usually, I have the panels at my lab space, 2 meter length and then the 1 meter width, the breadth, okay? Then what is the area of my panel? Can someone say, answer to me?
2 is the area.
What's that?
2 is the area, meters squared.
Yes, 2 square meters. You can say 2 square meters or meter square, whatever, right? Because you just multiplied L into B. 2 into 1, 2. And of course, meter into meter, meter square. So that's square meter, right? So this is a standard dimension mostly. Some, few millimeters changes will be there from manufacturer to manufacturer, but mostly you can, as of now, if you wanted to share my screen and show various companies and their dimensions L into B into H, mostly 35 mm is the height of that, and maximum, 2100, 2150 is the length. That is nothing but almost nearly close to the 2 meters, because 2150 mm is going to be somewhere centimeters, okay? So that is near about 210 centimeters are going to be almost close to 2 meters. You understand? That is very simple math actually, because you know that 100 centimeters makes a meter. Yes or no? So 10 millimeters makes a centimeter. These are all the very basic standard things. So ultimately what you all need to know, with my help, I'm giving you right away, instead you break your head. So I can tell you, usually the panel sizes these days very much standardized. Suppose, for example, for this commercial purposes and all, this 2 meter square panels are very commonly used. So they come with, 330 watt panel with polycrystalline technology, around 440 watts panel with monocrystalline, or some 540 watt panel and all with bifacial and all. So, so as the technology goes up in the same square area, you get more energy. So, but of course, you need to pay a little more cost for that particular mono and bifacial and all. But if at all in some area where the area is not at all a problem for you, you can use whatever area you want. So in that case, you don't have to invest that much of money, because return on investment is also very important. So then in that case, you can think of going poly, or in some cases like United States, you don't get the solar radiation the way we get in India. So in that case, you have to have mono instead of poly. Better you have to have a plan for monocrystalline solar photovoltaic module. So I request all my mentees to work with monocrystalline. Okay, and next we'll take a challenge with bifacial. But right now, for today's work, you just work out, and a monocrystalline is good enough for weather conditions of the radiation and all, because it is not that sunny, in the United States and all. So mono is going to be, even light sun rays comes also, you'll get a lot of energy. Okay, that's a mono technology, off-cut technology and all. So you start working with monocrystalline solar photovoltaic modules for today, and then find out, in the United States, who are all the suppliers to supply at 1 square meter area. Suppose say, what is the maximum power the manufacturer offering? Or suppose say 2 square meter area, 2 meter into 1 meter size panel. What is the power they are offering with the monocrystalline, and who are all the manufacturers, at what cost they are supplying? Like which are the companies, solar guys? I have no idea. I have no clue also. You need to find it out. Okay. Maybe which stores and all, which suppliers and all, you find out. Help me understand all that, because you are all my mentees. Okay. And you are all there, and you can do Googling and all, and you can make me understand all that stuff. Nikki, can you help me that? So you need to find out the vendors and suppliers. The store fellows and solar fellows, solar guys. Okay. Those who can, Sridharshit, I just want you guys to be like that. You can order them to come with, design is yours, because you know all the calculations. You have well calculated, well designed, and finally you are going to place the order. To whom to be played, this is very important. Okay. So you need to find out the vendors. So which vendor, with which company, which efficiency, and which standard productions they are offering. All these things we need to work on. If you want it to be a real, design person, you can do all that. Anyway, good. We have done a good discussion. I hope you understand. Giselle, you understood now what is that? So have you taken this? Once you understand this, then, for example, in 2 meter square area, on an average, if you come to a conclusion around 400 watts, you can produce. Okay. And then how many panels we required for our 25 kilowatt requirement of the Bank of Russia? Russia said she's working with the bank. So I told her bank requires around 25 kilowatt. Okay. So now who is going to tell me if I require 25 kilowatt? But however, with the monocrystalline technology, with the panel size of 2 square meter, 2 meter into 1 meter, okay, 2 square meter. That's a regular standard panel. You all can, rest of the things you are going to help me, Giselle. You are going to Google and find out which are the, I can tell from India, which are the panel manufacturers, and what are the efficiencies. If I share my screen and show you, you all will be amazed to see the background work which I have done for you guys. How much information I have collected and kept them open to show you the specifications of the catalogs. Maybe next or day after tomorrow, if you want, I can show physically all my collected information, around 100 kilograms of catalogs. I can show you guys how much data I refer. So at this point of time, you can Google them and find them and let me know back. Okay. So what is that I'm looking for? Who is going to use the common sense? Russia, can you help me? I need 25 kilowatt for your bank. But my one single panel of 2 square meter area sized one with a 2 meter length and 1 meter breadth, I can get only maximum 400 watts with the nanotechnology. Okay, for example, this is the case. Then how many panels I require? That is a question given by you guys yesterday. So now you need to do some math over there. I'm poor in math. I don't know. You have to do the math. Who is going to do that? Are you following me, Sridharshit? Are you following me? Do you follow me? Okay. if you follow me, because if you don't answer me, I'll be in trouble. Whether you follow me or not, I don't know. That's why. Okay, Giselle, 25 kilowatt, okay, 2 meters square. Find number of panels. Yes, do the math. Yes, you are correct. Do the math. How many panels I need? I don't know. For example, we have a better technology. Suppose my Russia has developed a new technology. Because of the new technology, she has developed a more efficient panel, so that instead of 400 watts, now my panel has come to that level. It is producing 500 watts, the same dimension, 2 meter length, 1 meter width. So 2 square meter panel. It is producing, because Russia has developed some new technology into that panel. So because of that, some more percentage of the power has gone up. So it is now producing 500 watts. Then in that case, how many panels I required to meet my bank requirement of 25 kilowatt? Simple math, very simple math. This is how I want my mentees to use common sense, to use your math. Little math. Naini, can you answer? Ankita, can you answer? Very simple. See, that's it. This particular whiteboard, whatever Cynthia has kept in front of me, I don't know how to use. I never used it. But I think that is for you guys to work on it, no? So you need to train me all this. But anyway, with our STEM programs, I understood how to use the breakup rooms and all well. So we changed to from room 1 to room 2 and all. I enjoyed that. But now this particular this whiteboard, you need to train me, Sridharshit. When are you going to train me? I don't know. I can train you guys in a power way, okay? All the STEM things. But not this. You need to train me. Giselle, are you going to train me this whiteboard? I never used it. Come on, yaar, do the math. Where is the answer for me? Okay, I'll go back to my Russia itself. Russia, are you there? I'm coming back to you.
Sir, I'm still doing the math.
Why, man? This is not that big math. You are taking years' time together. Very simple math. Okay, now I'll do one thing. Now, what my Nikki did, she has developed such other much more better panel. Now, in the same size, now Nikki's panel is developing in the same 2 meter square area, but now it is producing 1000 watts. Nikki's panel, Nikki's design, she is a scientist, developed the new science in the cell making, the solar photovoltaic module. There are so many cells, no? There are so many cells, series and parallel connected cells. So Nikki has developed a new model cell. Because of Nikki's new model cell, it is now the panel is producing, the same sized one, the 2 square meter, 2 meter into 1 meter, the same panel. Panel size has not increased or decreased. It is kept constant because we wanted to standardize some things to understand the science better. So, but in the same size of the panel, so that the old people, the previous solar installed people can remove the low power panel and use Nikki's panel. Now the panel capacity is 1000 watts. Then in that case, how many panels I require to meet Russia's bank requirement of 25 kilowatt? Russia, you need to answer me. This is for you. I thought for 400 watts, it is taking problem and you people are finding difficulty in doing the math. Then I went to modify with some other 500 watt panel, then also answer is not coming. Now I made it 1000 watts. To make your math more simple, then definitely I expect from Russia in next 10 seconds. Russia, what is your answer? How many panels are required to provide power through solar panels to your bank when the bank electricity requirement is 25 kilowatt? Come on, do the math fast because you need to work with the given task. What are all the manufacturers? What are all the various specifications and dimensions? All these are things you are going to work for next half an hour. I'll give 15 minutes. Breakup time in between, you'll need to do that. Anyway, I think Sridharshit, you need to answer me this. Now no one else is answering, so you are the only one who can answer me now. You better repeat my question. Naini, repeat the question. I wanted to know how many of you guys understand my question. What is my question? Can help? Yeah, go ahead, Naini.
I think, are you saying that it's 1000 watts per solar panel?
Yes.
And then how many to power 25 kilowatts?
Yes, Naini. Because
So
Nikki has
25.
developed a new technology. Nikki's panel is now producing 1000 watts in the same square, in the same area. We have not changed the dimensions of the panel. We just kept them, the length is 2 meter and breadth is 1 meter. So 2 into 1, 2 and meter into meter, meter square, 2 meter square. Now Nikki's panel is producing 1000 watts. But Russia's bank requires 25 kilowatt. Then how many such panels to be put on Russia's bank so that they can totally work with solar? Come on, Ankita, tell me what is the answer? Oh my God, no one is answering.
25.
How come you said 25? Naini, how do you know that 25 panels required?
Because 25 kilowatts divided by 1000 watts
Oh,
is
you
25.
understood 1000 watts makes 1 kilowatt. So 25 kilowatt means 25 into 1000. It is 25,000 and then you are divided by 1000. Then ultimately the answer is 25 panels you require. So you don't need any more units. That's simple number of panels. Okay.
I
Okay,
entered
fine.
the answer in the chat.
You already, wonderful. See, that's it. Yeah, you are right. You are correct. Okay, fine, good. So you guys now has come to this level now. Now, my next guidance given to you all for next 10 minutes, you all have to 10 to 15 minutes maximum for today's activity, okay? So you need to do the research. The research is, who are all the manufacturers, providers, suppliers, vendors there, because once you know the 25 panels required, so, especially I told you instead of polycrystalline in United States, definitely you need monocrystalline for better performance. So sourcing, you need to work with sourcing. Okay, you can start working onto that. Then you will understand the specifications. And then if you want to know the specifications, I can share and show you how the specifications look like. Then you also need to find out that kind of specifications and then maybe PDF files of that companies. You need to share the screen and show me later, collecting the information. And then if you have any questions from that specifications, I can try to help you guys. And finally, we'll come to a conclusion by maybe today's, before the session, that what kind of building require, what is the energy and what kind of panel with what kind of sizes and what kind of number of that kind of panels are required to be installed, all these things. And if at all the roof area is not sufficient for that particular specific building, like Gisel school building requires 45 kilowatt. Having a roof area maybe lesser than the the panel capacity, so a number of panels required, suppose say 100. And then Giselle school may not allow us to put on that many panels on the roof with some angle and all. Not possible to install all those number of panels because the roof is small. Because Giselle school is vertically constructed, not horizontally constructed. When the school building is vertical, then definitely you'll have lesser roof area. Okay, you understood? So apartments don't have to be horizontal. Apartments can also be vertical, maybe with the 4 floors or 8 floors or 12 floors. Then in that case, the people living in that building are more, and then their energy consumption, energy requirement is more, but unfortunately, they will have lesser roof area. In that scenario, what will be our solution and what will be our suggestion? What will be our design? You understand, Giselle? We can. Design thinking is something to think for our required designs. That's where the specialty of this design thinking STEM lab for you guys. So let us use our brains to think and come to conclusions, do the required background research. So who are all going to take the challenge? Who understands what exactly is my requirement? Can someone repeat what exactly is my requirement for this 15 minutes of work? Can someone? Yeah, go ahead, Nikki. What exactly is my requirement? For next 10-15 minutes, what is that I'm expecting you guys to work on? Rasha, are you there? See, if you guys keep the cameras closed, I don't know whether you are there or not. I don't know. So, okay, you are there. Rasha, you are there. Okay, I think you had all my 15-20 minutes of talk. Enjoyed? You understood some interesting? I know Sridharshit always knows that he always wants something more from me. I know. Every time he takes a lot much. So he enjoy a lot much. So today Rasha has come and joined. Okay, now the thing is, I need to know, okay, what exactly I'm looking from you guys, so that next 15 minutes you'll be working on. I'll be observing because you'll be putting onto the whiteboard. Then I'll be watching what is that you're all doing there. So what is that? Giselle, come on, tell me what is it I'm looking for. What is that?
You would like us to design a new inventive way to implement our solar panels onto our buildings? Can you hear
So
me?
already given the guidance required, so we don't have to really work with polycrystalline, okay? So directly start working with monocrystalline. So Google yourself, who are all the monocrystalline solar panels suppliers or vendors and solar guys are available maybe in Georgia, Atlanta, or maybe, I don't know, entire USA. Okay. But in India, I can share near about from near 200 different suppliers. I have that much of information collected. If you want, I can share my screen and show you how much work I did. But right now, you wanted to see the specs the way I'm expecting from you guys. Okay, you do and show me. Oh, sir, we found this PDF file with a lot of specifications. The open source, open voltage, open circuit VOC is this much, and short circuit current is this much. The panel sizes are this much, efficiency is this much, all these things, okay? Sridharshit inviting you to follow, ignore or follow. Sridharshit, do you want me to press the follow button? There is a message from Sridharshit. So I don't know. Actually, I never used this whiteboard. Do I need to press the follow button?
I didn't
Sridharshit,
press
no.
anything.
Say again.
I didn't press anything.
Oh, okay. But actually, Sridharshit inviting you
Something
to
is
follow.
coming on the whiteboard.
Oh yeah, it has come on the whiteboard. I don't know whether I never used this whiteboard, so I don't know what to do. Shall I click on the cross mark? Ignore. I just ignored. Okay. Yeah,
Just
it went
ignore.
off. Oh no problem. Okay. Yeah, come on. So this is what information I'm expecting from you guys to do the required research and help me understand so that I can also help other guys to install solar panels in USA. If you can help me. Giselle, will you work with me to make me understand? So that, at what area, what is the maximum power you get out, to do the required research and find the PDF files, okay, from different suppliers and vendors. Because any manufacturer, they always keep their product catalogs online. So go to them and find out them and then refer them. You don't have to understand all the, details of that specs, but at least come with some questions. I found this catalog, from this catalog, I found many of the things, but what are all these things? You can ask me. So I look forward for all your questions. To do the math, do the research for 15 minutes and get back to me. Start working. This time starts now. It is, what is the time now?
12.
Exactly 12. Okay. By 12:10, finish it off. 10 minutes, more than sufficient. Google.
Just to clarify, you want us to look for providers on monocrystalline solar
I
panels?
don't want, suppliers' names and all. I want the technical specs of all the products. Solar panel products. Maybe with monocrystalline, having the L and B like 2 meter by 1 meter. They usually mention with millimeters. Okay. So you just check it up. That is around 2,150 mm length, maybe 1,125 breadth. This kind of 35 mm usually is the height, thickness of the panel. So you can go with this kind of requirement. So start finding out local suppliers, manufacturers, and the big good companies with good repo, and open up their catalog, these things, and then find the PDF file, or even you can use the file type semicolon PDF for your required keyword. Monocrystalline, solar photovoltaic module, file type, semicolon, PDF. That's it. You will get a lot of PDFs. And open the PDF and see, try to understand what are the specs given on the PDF. And then ask me and show me. Then I will understand your work. Every single, my friend, need to at least share 3 or 4 catalogs. Then I'll understand you are doing good background work. Nikki, are you doing? I know you will do better work. Do. Nani, are you following me?
Yes, sir.
Okay, good. Russia, don't bother about the number of vendors, okay, close to 50,000. Don't bother about the number of vendors. They'll be there. We don't really bother about all the number of vendors, okay? We'll take out, we'll try to understand good product. First, we'll try to understand good product available there at Georgia, Atlanta. So, good makes. Like I can tell you in India, there are 10 to 15 very good companies. I can tell you the names of the manufacturers, exporters. Likewise, you need to find out from there so that you can see their product catalog. That is how you learn. Then based on that, your work, we'll go and start working on your today's assignment. Without this information, You won't be able to do yesterday's work. So that you can start counting the roof area of your selected buildings. And by using this particular good product, what is the maximum you can get out and how much they really require. Then if it is more available, less usage, good, fine, happy. If it is more demanding, more requirement, but less available on roof, we'll use our minds to do some other designs. We need to work onto that. That's going to be our homework for today. Yeah, Nikki, go ahead and tell me. I just see your hand raised. Yeah, go ahead. Nikki, go ahead. You have a question? You have done the work? Nikki, I just found your hand raised. Do you need this whiteboard or you want me to remove the whiteboard?
You
You
can
guys
remove it.
Anybody need the whiteboard there or shall I remove it?
Remove it.
Okay. Yeah, go ahead, Siddharshit. Are you ready?
No, I'm still researching.
Do that, do that. I hope you're enjoying my mentoring. Yes, anybody is ready? Giselle, are you doing?
I have four products.
Oh yeah, wonderful. Excellent.
Thank you.
You want to share and show me?
Sure. Yes, sir.
Better.
Would you like me to share my screen?
Yeah, and show me the specs.
Okay.
Any PDF file? You got a PDF file?
I have websites and then I have let me
Okay, no problem.
okay, so here are the websites. And then
Oh, from there.
I'll just so here is one product which
Mhm.
has 480 watts
Good, good.
with these various designs.
Yeah.
And
Just show me
then
that. No, show me that the watts. Show me the watts. So next up to that is that efficiency is very interesting. Okay.
19%
And,
efficiency.
Yeah, that's good. And even 30 years, that is good. Okay.
For the next product, I found
This is important. This is interesting. Yeah, very interesting. Scroll up. It is 380 watt panel. Wonderful. Yeah, scroll up. Scroll up.
oh sorry.
It is good. It's off-cut and monocrystalline panel. Wonderful. 380 watts is very good. Yeah, I think this is the 2 square meter area panel. Okay, I understand that. Okay, yeah. Scroll up. I just want to ask you. I want to train you onto some other specs. Open it up. Scroll next page. I mean, scroll up.
Okay.
Yeah.
So
You stop
here's
there. You stop there. The electrical data. Oh my God. So all my students need to understand this. The maximum power. Okay. That is P max. And the maximum voltage. The panel can give you at the maximum voltage you get out of the panel based on the maximum sun coming onto that panel. That's more important. And the maximum current, open circuit voltage is also important. When this panel has not connected to any load, then it will offer that voltage, open circuit voltage, VOC. That's called VOC. Okay, that's very important. So short circuit current is also important. These are the very important specs. Very good manufacturer specifications are there here. Interesting. So I think you can go ahead with this panel. I mean, okay. Yeah, the dimensions. Can you see the dimensions? Yeah, you see it's a little lesser panel. You know, the 1725, 1134. That is less than 2 meter. That's where it is giving less power. The panel size is less. We need to go for next because we are discussing with that 2 square meter. I mean, 2 meter by 1 meter. This is 1725 into 1134 into 35. The 35 is anyway standard for all the panel manufacturers. That is the thickness of the panel. That has to be standard. But however, L into W, yeah. So mechanical data. You need to refer the mechanical data. I mean, the dimensions, very important is the dimensions and the weight too. Weight also important and the dimensions are. So you are interested in working with inches. I'm not that familiar with inches, okay? Because, inches means again feet and square feet. So usually many of the countries work with millimeters, centimeter and the meters. So square meters is a common most important unit for measuring sun energy and all. Of course, square feet also, but that is a smaller unit, okay? So you can understand how many square feet can be accommodated in 1 square meter area and all. That's the math. You need to go on to conversion square feet to square meter and all that. Anyway, so this particular panel, this manufacturers offering with lesser, sizes, 17, 25, 1134. They are the little lesser sizes. So find out some other manufacturer so that those, minimum 2000 into 1100. So 35 is anyway is going to be common. I have seen one company is making the thickness of the panel with even 45 mm also for more better strength and all, but we don't have to really bother about the strength right now. We need to understand the electrical parameters more than the mechanical data. So go ahead and find out some other, Giselle, do some other math, okay? Okay, you can close this one for now and go ahead and show me something else if you want, or otherwise I'll ask someone else to open something else. Yeah, this is how.
Okay,
You
thank
don't
you.
have to. You don't have to really only work with one company. Okay. Ultimate, our goal is to work with 2 square meter nearby area, giving around minimum 400 or above 400 watts of the energy. That is with monocrystalline technology. So that is how we need to. Because I'm away from United States, so I don't really. When I'm there in United States, I can do lot much research. I think I'll come there to work with you guys. But you need to raise yourself to that level so that I can come there and work with a big way, in a most practical way. For India, yes, I can do lot much. So let's do that. So raise yourself, enjoy the design thinking.
Okay, thank you.
Yeah, and now who is going to share the screen? Giselle, do whatever best collection information you do, okay? Keep them, save them in a folder. And again, and we can. Yeah, go ahead, Nikki, please. Share your correction, whatever work you have done, because we are running out of time. We have to do lot many tasks in time. If your train, if our flight runs with a lot of late, then we won't be able to catch up. Okay. He is going to share the next. Naini, are you ready with your research?
Yeah, I can say what I have. I can't share my screen because I'm on a phone. So
Okay. Oh, okay, I understand. Oh, no problem. No problem. Otherwise, use your laptop for connecting. I think because of your phone, I think better voice. I'm getting your better voice. Okay. But I think after this session, I think you better plan, ask, Senthil or Murli to work with your mic so that we can work with your laptop and then better quality. Okay. Otherwise, I really wanted to work more with you, but only with a better quality of audio from your side. Yeah, Nikki, go ahead. Yeah.
Okay.
Yeah, share some of your work. No problem. See, Darshit, no problem. Have the idea that you need to do. Find such data. Otherwise, I can share my screen and show. Yeah, this is good. This is really good, Nikki. You always do something interesting. Yeah, this is the data I really look for. We don't have to worry about, which manufacturer.
This is the mono, whatever this word is.
One
This
second.
is the solar panel.
And Nikki, is it your data?
Yeah.
Oh, wonderful, wonderful. Yeah, go ahead. Hey, your panel has offering me 450 watt. My God. Under standard temperature, STC, under that particular STC, it is 450 watts is good. With a cell efficiency of 22.8. Oh, it's really good. Good. Yeah, you found a good panel. You found a good panel, Nikki. But now I need to know what is the size of this panel. Then I can say you have done a good job. Or otherwise, 450 watts and 22.8 efficiency, that's all good. They're good specs. The open voltage and the short circuit current, everything is excellent. But I just need to know whether it is within the 2 square meter. I mean, the length is 2 meter and 2 into 1, or what exactly is the dimension? Which make is this? Which model is this? Hopefully, mostly this is going to fit our requirement. Okay, I don't know which make you found out, but you can take out the company's name or the supplier name then you can do better research. Anyway, you know how to understand, finding the spec of a panel. Yeah, happy?
What in the regular solar panel? What in
Now
it
I need to
be
know
like?
from you, Nikki. Everything is fine from you. I just need to know what are the dimensions of this panel? L into B into H, L into W into H. If it suits, L is near about, 2100 or some millimeters, that's good. That's sufficient. And then automatically W is going to be around 1100 mm or something like that. And anyway, the width, the thickness is going to be, yeah, that's true. Yes, exactly. You are drawing, no? Yeah, those dimensions I just want. The taller one is the length. And, the thickness 35 mm is going to be standard, that you don't have to really worry about. Okay. So other two, I need to know from you. If you can tell me those two, then you are done. Okay, now, yeah, I'm going for next. Someone else, please. I just want to verify with someone else.
Hold
Anyone
on.
has done? Anyone has done? Then if anyone wanted to share their data collection? Anyone has done? Okay, now, as you all know that, I've given you a good thought that, almost 2 square meter of present today's efficient panel, 22.8, Nikki has given the panel with a good efficiency. Earlier, one panel, Giselle has shown me, that is only 19% efficient. But now Nikki shared the panel with a spec of 22.8%, So that's one thing. Anyone, whoever wanted to become a good scientist, they can, try to understand the material science. And then if they can start doing research onto that area to develop the efficiency much, much better, so that in the same area, they can have the more power. Okay. So that's a different scenario. Now, I think we'll take a second question. Today's our second question. How many of you wanted to work with? So second question is, where is my Russia? Russia, are you there? I don't see her. Because she told me that she wanted to work with her bank building. I don't know she's there on the call or not. But anyway, how about Nikki? Are you there, Nikki? Nikki, which building you are taking for your next step? Any building? Have you chosen any building? Have you chosen any building? Have you selected any building? Which building you wanted to power with solar? Which building you wanted to?
The Museum of Atlanta.
Okay, you can type the building name into my chat box, and I'll also do my research from here. What is the roof area you have there? But make sure, Nikki, you need to know how much power they require for that building. If you do without knowing that, there won't be a point to work on the building. So you need to know how much energy that building wants. Your residential building or your school building or any commercial complex close by, I don't know. You need to work on. Okay? Okay, Nikki? So just type that building name so that I can also Google it and find out. I can see through my Google map and see the area of the building available. And then I need to check how much area I can make use for putting my solar panels out there, all that, right? Okay. Now, Nikki, you have to come with that. And then next, Giselle, are you there? Giselle, are you there?
Yes, I'm here.
Okay. Then which is the building you have selected?
I selected Truist Park, Truist Plaza.
So, but do you know how much energy they require?
I believe it's, let me find it.
In United States, mostly you can Google them and then the data is available online because most of the activity there in USA, they are there with online information. You can do that as well. Okay, that's one thing. Second thing, even if you don't get the data, don't really worry about it. And you can assume based on the available roof out there. So you can start for today's second question that you need to find out how much area they have on the roof. And then in first condition, if they allow us to keep all the, use all the available roof, that's first condition. If at all the landlord of that particular building premises, if they allow only 50% roof area to be used, second condition. And then in third condition, if at all they don't allow us to use the roof, what else we can do? What else we can do? Nikki, understand? There are three conditions for today's task. First condition is the entire roof can be used. There is no problem at all. Whatever is there, we can use it. In second condition, they allow only 50% roof area. The rest of the 50% they don't allow. They want for something else, okay? And in third condition, they don't allow at all. On the roof, they don't allow, but they'll allow in some other areas, but not on the roof. So how do we think different? Thinking different with out-of-box ideas is design thinking. So will you take the steps of all this? You know the steps of design thinking. Right from the beginning project, you are all doing. You're all going through all the 5 steps, right? So anyway, you all know the first step with empathy and all that you know well, right? That's where we are all taking these problems. Anyway, so you wanted to close your research today itself, or you wanted to work for the next day? How many guys wanted to finish off your finding, calculating roof area now itself? And then how many panels can be used on that roof for all the 3 given conditions? You know the 3 given conditions. Nikki, you know, no? First condition is you can use all the roof. Second condition is, what is the second condition? Tell me, no.
Roof. Half roof.
Second condition. What is the second condition? Because in STEM education, in the design thinking, we always will have options. We'll work with options, different conditions, different situations. So we need to have, we don't end up with only one solution. We always keep open for various parallel, possible, productive ideas.
We need to close the session now.
Second one. What is the second condition? I gave 3 options. You all have to work for all those 3 ideas. Otherwise, how I can raise your critical thinking in a creative way? Yes, Sridharshit, you understood what is my given task? What is the second question? Second option. What is the second requirement I am looking for? You are not you are not there at that time, Sridharshit. Your audio is not coming to me, Sridharshit. Say hello, say hello. You are not on mute. Okay, you are not on mute, but somewhere, somehow, your mic might be pulled out. You can check your mic. Because the software only knows whether you're purposefully muted or not. But physical connection, your software don't know. So if you have removed the mic pin out from your mic socket, then I won't be able to get your audio. Okay, I'm good in electronics. I'm a good designer. I used to enjoy making audio systems while I'm there at your age. I enjoyed all conversion of sound into electrical signal and then preamplifier, power amplifiers. Oh my God, I used to make a lot of very good melodious audio systems while I'm there in school at 6th grade, 7th grade. That's my business. Later I did many more things. I'll share later. Okay. So So yeah, what is your final? Tell me, shall we wait for this topic to be completed, or shall we take it as a work for the tomorrow? Yeah, Nikki, what is your option? You wanted to complete the task given now itself? Okay. Giselle, how
Hi,
about you?
sir. Hi, sir. This is Murli Padala. I think,
Murli, yeah, please tell me. Yeah.
yeah. Hi, sir. I think they want to research on this topic and come back tomorrow to, about, I think all the kids, so they will, so those three issues that you're saying, like full roof, half roof, and no roof solution,
Yeah,
how
if
to
at
come
all,
up
yeah.
with,
If at all
yeah,
permission is
yeah.
not given,
So
then what is the option? Yeah.
what is the option and how to do that, and how much will they be able to save?
Yes,
Basically,
yes.
that is the question, right? Yeah.
And
So
also,
they will
whatever
probably,
building they select, what is the energy requirement for them? And today's based on the given subject knowledge, how they can design the things and all. These are the things we need to complete.
yeah. So
Okay, then.
So I think they can make a few lines on like the building name, the amount of energy required,
Yeah,
and with these solar panels, how many solar panels can they use from the based on the square footage of the roof,
yeah,
and based on the production of the solar panels used, how much they can offset or completely replace the electric input. And once
exactly.
if they are done with that,
Yeah,
that would be a presentation for tomorrow. So all kids can at least have one like a paragraph or like 4 sentences each, and they should be done. So they can
exactly.
do the research for tomorrow. Yeah. So
Sure,
for
sure.
today, I
No
guess
problem.
all of them, yeah, it should be,
Okay.
yeah.
Okay, Zizel, take care. Have a nice day, all of you guys. Naini, Nikki, and then
Okay.
Sridharshit. All of you guys. Have a nice,
Bye.
wonderful day.
Thank you. Have a
Bye-bye.
nice day.
You
Bye.
too, guys.
Bye.
And have as many questions as possible, okay? Questions are more
Thanks.
interesting for me.
Can you
Write
post all
down
the questions in the chat?
Yeah, better.
Yeah.
That WhatsApp chat, if you can share me, I'll go through your questions and I'll try to share my whatever best I can. Okay.
Okay, Naini, I will ask Naini to consolidate all the questions that you need an answer for tomorrow.
Okay.
So
For
you
1
can put
minute,
it in.
1 minute, can I share my screen and show little my research now? How
Yeah,
much?
sure.
Oh, 1 second. Say, all of you are okay. Be ready. I'm going to share my screen and then. See, my dear guys. See, I already opened up my, many. You see, exact I think you all able to see. Yeah. So
Yeah.
see, this kind of data I kept them ready, and you see, all this so many. I'm going to show you. There are so many different manufacturers, and then. So in fact, this is not online. This is all offline. I have visited many expos in India. And then I have collected a lot of information through catalogs, and then I have referred all of them for you guys. Okay, and then you see the dimensions and cell number of cells and the dimensions here, and then okay. So this is in the little time, and then I just wanted to how the specs works for you guys with all that. Now what I'm trying to do, let me close down these particular catalogs. Let me open up my folder. Okay, suppose say what I did today, as I told you, I have a lot of collections. So in all that collection, so what I did, I just scanned, physical this catalogs. I was just scanned for you guys so that I can, you see, for example, now if I do next, then you will be able to see. See, in 1 minute, I can show you how many catalogs based on our solar photovoltaic modules and solar related cables and, the solar based, say what I mean to say,
Well,
on-grid inverters, off-grid inverter, and hybrid inverters. There are so many, structural parts and
Yeah.
whatnot. Okay. So anyway, so what we'll do is we'll do a special mentoring session with all of you guys by taking permission from Cynthia, and then we'll do a big session. There I'm going to elaborately explain, maybe in 1 or 2 sessions. And then also through my PPTs and all, I have specially developed all of them. For now, I think the given task is ready for you guys to start work. Okay. So the task is very clearly, it is clearly known to all of you guys. So have a nice day. I hope, yes, Cynthia, you are there. Yeah. Go ahead and tell.
she, I think, no, she, as I said, she had to go for a meeting. So this
Oh,
meeting, the laptop is on,
Okay,
but
Murli,
she is
okay.
not here right now.
No problem, no problem. Yeah.
Yeah.
Yeah,
Thanks.
no problem. Okay, Giselle. Okay, Sridharshit. Okay,
Say
Nikki.
bye, guys.
Bye bye.
Bye.
Bye, Uncle. Bye, Share.
Take care. Bye bye. Have a
Bye.
nice time living